Scientists say it's a matter of when, not if, there will be a major earthquake in the new Madrid Seismic Zone.
In the heart of America, just south of St. Louis, the new Madrid Seismic Zone quietly awaits its next move. And something just emerged there that has terrified the whole world. Known for past earthquakes, this area silently lies beneath our feet, and scientists are not sure what it will do next. As daily life continues overhead, the potential for future earthquakes remains a topic of scientific study and community concern. But what was just discovered here, and why will it change how we view the world forever?
Is the St. Louis area next? Seismologists say it is not a matter of if one will hit, it's a matter of when.
Join us as we explore what lies beneath and understand the realities of living with this seismic neighbor. The new Madrid Seismic Zone. In the heart of the United States, not too far south of St. Louis, lies an area known as the new Madrid Seismic Zone. This might not be something you've heard about every day. Back in the early 1800s, specifically between 1811 and 1812, this area was the site of some of the largest earthquakes ever recorded in the continental United States. Imagine waking up one day to the ground shaking so hard that it changes the course of rivers, creates huge cracks in the earth, and even makes the Mississippi River appear to flow backward. That's exactly what happened during these earthquakes. It was a terrifying time for the people living there, and the landscape of the area was forever altered. And now, a recent discovery has emerged here that has left the world terrified of what is to come. Today, scientists are still keeping a close eye on the new Madrid Seismic Zone. Recent discoveries have shown that this quiet giant is still very much alive. Small tremors and shakes are common, serving as a constant reminder of what lies beneath. Researchers are using the latest technology to monitor the area, trying to predict when the next big earthquake might occur. While it's hard to say exactly when that will be, the consensus is clear. It's not a matter of if, but when. The potential risks of a future significant earthquake in this zone are not to be taken lightly. With a densely populated area above it, the damage could be extensive. Buildings, bridges, and roads could be affected, not to mention the impact on people's lives. This is why current research is so important. By understanding more about the seismic activity in this area, we can better prepare for what might come. So, while the new Madrid Seismic Zone might not make headlines every day, it's a fascinating and crucial area of study for scientists and a significant point of awareness for everyone living in its reach. The history of the 1811 to 1812 earthquakes serves as a reminder of the Earth's power, and the ongoing research into this seismic zone helps us stay one step ahead. The most notable period in the new Madrid Seismic Zone's history occurred between December 1811 and February 1812. During these months, the Earth unleashed a series of powerful quakes that forever altered the landscape and the lives of the people living in the area. The first of these quakes struck in the early hours of December 16, 1811. It was so powerful that it reportedly rang church bells in Boston, over 1,000 miles away. The ground shook violently, creating huge fissures in the earth, and even causing the Mississippi River to flow backward temporarily due to the uplift of its bed. Following this initial quake, 2 more major tremors were felt over the next 2 months, each causing widespread damage and fear among the region's inhabitants. The land rippled like a liquid in some areas, swallowing trees and creating large lakes where none had stood before. Eyewitness accounts describe the night sky glowing red with the reflection of massive fissures opening in the earth, a phenomenon that has led to much speculation and study. These historical earthquakes were remarkable for their strength and for their vast geographic impact. The tremors were felt as far away as New York City and even Canada, covering an area of roughly 1 million square miles. This widespread effect is partly due to the geological characteristics of the region, where seismic waves can travel long distances through the ancient, rigid rocks of the North American craton. In the years since these early 19th century events, the new Madrid Seismic Zone has remained active, though no subsequent quakes have matched the intensity of the 1811 to 1812 series. Scientists continue to study this area closely, as it represents one of the most significant seismic risks in the eastern United States. Ongoing research aims to understand the potential for future earthquakes, their likely magnitude, and how best to prepare for them. Today, advancements in seismic monitoring and earthquake preparedness have significantly improved our ability to respond to potential seismic events. The lessons learned from studying the new Madrid Seismic Zone's past earthquakes have been instrumental in developing these strategies. Communities in the region participate in drills, buildings are constructed with seismic resilience in mind, and early warning systems are in place to alert residents of imminent seismic activity. Understanding seismic zones. But how exactly do seismic zones work? Seismic zones and fault lines are like the cracks and creases on the surface of our planet. Just like how a paper folds and bends, the Earth's crust has these lines where it can move. Seismic zones are areas where these movements happen more often, causing earthquakes. So how and why do earthquakes happen? Earthquakes are like holding a twig. If you bend it slightly, it can spring back to its original shape. But if you bend it too much, it snaps. Similarly, the Earth's crust can only stretch so far under pressure from moving plates before it breaks, releasing energy that shakes the ground, which causes an earthquake. The new Madrid Seismic Zone has its own set of unique characteristics that make it stand out. Unlike many other seismic zones located at the edges of tectonic plates, the new Madrid Zone is in the middle of a plate. This is unusual because most earthquakes happen at the boundaries where plates meet. In the early 19th century, this area surprised everyone with some of the most powerful earthquakes ever recorded in the continental United States. What makes the new Madrid Zone even more intriguing is how it behaves. The earthquakes here in the 1800s were felt over a vast area, far larger than would be expected for quakes of their magnitude anywhere else. This is partly due to the type of ground in the central and eastern United States, which can transmit seismic energy farther than the more broken-up ground on the west coast. Understanding the new Madrid Seismic Zone helps scientists and communities prepare better for future earthquakes. By studying this zone's unique characteristics, researchers hope to uncover more about how earthquakes can happen in the middle of tectonic plates and what signs might precede them. This knowledge is crucial for improving safety measures and reducing the risks posed by these natural events. The new Madrid seismic isn't the only dangerous part of the Earth. Many others around the world exist that have their own unique characteristics. The Ring of Fire. The Ring of Fire sounds like something out of a fantasy novel, but it's very real and one of the most fascinating areas on our planet. It is a giant ring in the Pacific Ocean, stretching about 40,000 kilometers. It's not a perfect circle, but more like a horseshoe, and it's lined with a lot of volcanoes and fault lines. This area is where the Earth is very active, shaking and erupting more than anywhere else. But why is the Ring of Fire so important? Well, most of the world's earthquakes and about 75% of the world's volcanoes are located here. It's a hotspot for natural events that can affect millions of people living around the Pacific Rim. A couple of big events have happened in the Ring of Fire. In 1991, the Philippines faced one of the biggest volcanic eruptions of the 20th century from Mount Pinatubo. The eruption was so massive that it cooled the entire planet's temperature for a year. The amount of volcanic ash and sulfur dioxide ejected into the stratosphere created a global layer of sulfuric acid haze. This layer reflected sunlight, reducing global temperatures by about 0.5 degrees Celsius. The effects were felt worldwide, showcasing the impact that events within the Ring of Fire can have on the entire planet. Before the eruption, scientists were able to predict the event and evacuate thousands of people, saving countless lives. Then there's the Tohoku earthquake in Japan in 2011. This was a huge 9.1 magnitude earthquake that caused a massive tsunami, leading to significant loss and damage. The tsunami waves reached heights of up to 40 meters in some areas, traveling up to 10 kilometers inland. The disaster affected hundreds of thousands of people, and the subsequent nuclear meltdown at the Fukushima Daiichi nuclear power plant added a prolonged crisis to the immediate disaster. Over 15,000 people lost their lives, with thousands more injured and displaced from their homes. The economic cost of the disaster is estimated to be in the hundreds of billions of dollars, making it one of the most expensive natural disasters in history. The Tohoku earthquake also highlighted the incredible resilience of the Japanese people and the effectiveness of Japan's disaster preparedness and response systems. Despite the scale of the tragedy, the country mobilized a rapid and efficient response, and recovery efforts began almost immediately. These events in the Ring of Fire illustrate the raw power of nature and the potential for significant impact on human civilization. Monitoring and being prepared for these kinds of events is crucial in the Ring of Fire. Countries in this area have set up advanced systems to watch for signs of earthquakes and volcanic eruptions. This includes using special equipment to measure the Earth's movements and setting up early warning systems to alert people when an earthquake or volcanic eruption is about to happen. Efforts to stay prepared also involve educating people about what to do in case of an emergency, practicing drills, and building structures that can withstand earthquakes and tsunamis. It's all about reducing the risk and making sure that people are as safe as possible when nature shows its power. The Alps Belt. Another notable seismic zone is the Alps Zone. The Alps Belt might not be as well known as the Ring of Fire, but it plays a significant role in the Earth's seismic activity. Stretching over 15,000 kilometers from the Atlantic Ocean all the way to the Himalayas, it's a major seismic belt that includes many of the world's mountain ranges, like the Alps and the Himalayas. This belt is the result of tectonic plates pushing against each other, causing the Earth's crust to fold and create mountains. Now, how does this compare to the new Madrid Seismic Zone? Well, the new Madrid is in the middle of a tectonic plate, not at the edge where two plates meet, which is more typical for seismic activity. This makes the new Madrid zone quite unique. While the Alps Belt has a history of creating some of the world's highest mountains through the slow process of plate movement, the New Madrid Seismic Zone has shown us that significant seismic activity can happen away from plate boundaries too. Throughout history, the Alps Belt has seen some notable earthquakes. One example is the 2009 L'Aquila earthquake in Italy, part of the Alps Belt, which caused significant damage and loss of life. This 6.3 magnitude earthquake struck in the middle of the night, collapsing buildings and leaving thousands homeless. It was a tragic reminder of the importance of building codes and earthquake preparedness in regions prone to seismic activity. The city's rich historical buildings suffered extensive damage, highlighting the vulnerability of cultural heritage sites to natural disasters. Another significant event in the Alps Belt was the 1999 Izmit earthquake in Turkey, which measured 7.6 on the Richter scale. It resulted in the loss of over 17,000 lives, with extensive damage to homes, infrastructure, and historical sites. The earthquake's impact was exacerbated by the density of the population in the affected area and the lack of seismic-resistant construction. It prompted a nationwide review of building codes and an increased focus on earthquake preparedness and response. This and other earthquakes in the Alps Belt remind us of the potential for future seismic events along this extensive zone. The seismic history of the Alps Belt shows that while its earthquakes might not always be as frequent or as widely felt as those in places like the New Madrid Zone, they can be just as impactful. The 2003 Bam earthquake in Iran, also part of the Alps Belt, further underscores this point. With a magnitude of 6.6, it caused the deaths of over 26,000 people, and the ancient citadel of Bam was almost completely destroyed. These events serve as somber reminders of the seismic risks that countries in the Alps Belt face and the ongoing need for vigilance, research, and preparedness to mitigate these risks effectively. Looking ahead, the potential for future earthquakes in the Alps Belt remains. Scientists continue to monitor the belt closely, using modern technology to better understand the movements of the Earth's crust in this region. By studying the past, they hope to gain insights that can help predict and prepare for future events. The MidAtlantic Ridge. Much like the Alps Zone, the MidAtlantic Ridge is equally fascinating. The MidAtlantic Ridge is like the spine of the Atlantic Ocean, stretching from the Arctic all the way down to the Southern Ocean. It's a giant mountain range that's mostly underwater and it plays a huge role in how our planet looks and behaves. One of the most important things the Mid-Atlantic Ridge does is seafloor spreading. Imagine the Earth's surface is like a giant puzzle, and the pieces are constantly moving. The ridge is where new pieces are being made, slowly pushing the old ones away. This process is part of what we call continental drift, which is why the continents are slowly moving apart from each other. This movement isn't just about land and water, it can also cause earthquakes. As the new crust forms and pushes out, it sometimes moves in jerks, shaking the earth. These quakes under the sea are usually small, but they're a reminder of the powerful forces at work along the Mid-Atlantic Ridge. But the ridge isn't about rocks and quakes. It's also home to an amazing variety of life. The process that creates new seafloor also brings up heat and minerals from deep inside the earth, which fuels life in the dark depths of the ocean. Around the ridge, there are vents spewing hot water, and these vents are oases for creatures that can't be found anywhere else. From tiny bacteria to big tube worms, life thrives in this extreme environment, showing just how adaptable nature can be. So, the Mid-Atlantic Ridge is a fascinating place. While it might not be as visible as mountains on land or as dramatic as a volcano erupting, it's a vital part of our planet's geological activity and proof of the ongoing story of Earth's constant change. Himalayan Seismic Zone. The Himalayan Seismic Zone is a place where the ground tells stories of the Earth's restlessness. Nestled among the highest peaks in the world, this zone is a critical area for understanding how the Earth moves and shakes. Historically, this region has witnessed some devastating earthquakes. Each event reshaped the land and also impacted millions of lives. For instance, the 2015 earthquake in Nepal was a tragic reminder of the power hidden beneath the Earth's surface. Buildings crumbled, villages were destroyed, and thousands lost their lives. These historical quakes serve as a warning of what could happen again. Scientists are hard at work trying to unlock the secrets of earthquake prediction in the Himalayas. They study past events, analyze the movements of the Earth, and use sophisticated tools to monitor the seismic activity. However, predicting earthquakes remains a significant challenge. The Earth doesn't give away its next move easily, making it hard to say exactly when or where the next big quake will strike. This ongoing research is vital. It helps communities prepare for future earthquakes, building stronger structures, and developing emergency response plans. While we may not be able to predict every earthquake, understanding more about the Himalayan seismic zone allows people to live alongside this mighty force of nature with greater awareness and readiness. Iceland's volcanoes. While these zones cover a huge amount of area that is under threat, some countries have their own unique set of dangers. Iceland is a land where fire meets ice, with its landscape sculpted by both volcanic activity and seismic movements. This unique interplay makes Iceland a place of stunning natural beauty and a key area for scientists studying how the Earth works beneath its surface. The country sits on the Mid-Atlantic Ridge, a massive underwater mountain range that's a hotbed for volcanic and seismic activity. This location means Iceland is constantly growing as new land is formed through volcanic eruptions. But these processes also cause earthquakes, as the tectonic plates beneath the island nation shift and move. In Iceland, volcanoes and earthquakes are closely connected. An eruption can lead to earthquakes, and seismic activity can indicate an impending eruption. This relationship is a crucial area of study for scientists, as understanding one can provide insights into the other. For instance, when magma from the Earth's mantle pushes towards the surface, it can cause the ground to crack and shake, leading to earthquakes. Monitoring these tremors helps scientists predict when and where a volcano might erupt. Ongoing research in Iceland focuses on improving earthquake prediction methods and understanding volcanic activity's role in seismic events. Despite advances in technology, accurately predicting earthquakes remains a significant challenge. The Earth's processes are complex, and many variables can affect when and how strongly an earthquake will strike. Scientists use seismometers to track the Earth's movements and try to identify patterns that might precede an earthquake. However, nature doesn't always provide clear warnings, making prediction difficult. Japan's dual risk. Much like Iceland, Japan sits in a unique spot on the globe, where the challenges it faces from the Earth's movements are doubled. It's part of the Ring of Fire, the horseshoe-shaped area loaded with volcanoes and seismic faults that circle the Pacific Ocean. But Japan also has its own intricate web of faults beneath it, making the country especially prone to both earthquakes and volcanic eruptions. The Ring of Fire brings Japan its share of volcanic activity. Volcanoes like Mount Fuji are iconic landscapes, as well as active reminders of the country's volatile position. Alongside these looming giants are the seismic risks. Earthquakes are a regular part of life in Japan, some of them powerful enough to cause significant damage and loss. Japan's own seismic landscape is just as complex. Beneath the country, multiple tectonic plates meet and grind against each other. This constant pressure builds up and, when released, causes earthquakes. This setup increases the frequency of earthquakes and the variety. Japan experiences different types of quakes, from deep ones that shake broadly to shallow ones that are more destructive. The dual risk from the Ring of Fire and its internal faults means Japan is one of the most earthquake-prone countries in the world. But it's also a leader in preparing for these events. The country has developed some of the most advanced earthquake detection and response systems. Buildings and infrastructure are designed to withstand shaking, and regular drills ensure that people know what to do when the ground moves. One of the most harrowing events in recent history was the 2011 Tohoku earthquake, a magnitude 9.0 quake that not only caused extensive damage on land, but also triggered a devastating tsunami, leading to the tragic loss of thousands of lives and initiating a nuclear crisis at Fukushima Daiichi. This event highlighted the relentless force of nature and the fragility of human constructs in the face of such power. Volcanic activity is also a significant part of Japan's natural landscape, with Mount Fuji being one of the country's most iconic yet dormant volcanoes. However, other volcanoes like Sakurajima and Mount Aso show more frequent signs of life, periodically dusting nearby cities with ash and reminding residents of the Earth's fiery breath beneath their feet. These natural events, both awe-inspiring and terrifying, shape Japan's approach to disaster preparedness and resilience, driving innovations in earthquake and volcanic activity monitoring, building technology, and community safety measures. Research into predicting earthquakes and volcanic eruptions is ongoing. Scientists use a network of sensors across the country to monitor seismic activity and try to give early warnings. While predicting exactly when and where an earthquake will strike is still beyond reach, these efforts have saved lives by giving people precious seconds to take cover. Japan's situation teaches us a lot about living with the Earth's dynamism. It shows how understanding and preparation can make a significant difference in facing natural disasters. Japan's dual risk from the Ring of Fire and its own seismic complexities makes it a key area for research, hoping that one day, the impacts of these natural events can be minimized even further. Indonesia and the Sunda Arc. Another country like this is Indonesia. Indonesia sits on the Sunda Arc, a curve on the Earth that's as beautiful as it is dangerous. This place is where the Earth really shows its power, with both volcanic eruptions and earthquakes happening more often than anyone would like. The Sunda Arc is not a random spot on the map. It's where two huge pieces of the Earth's crust, called tectonic plates, meet and interact. One plate slides under the other, a process that can create both volcanoes and earthquakes. Indonesia, lying right on top of this arc, faces the consequences of this deep Earth movement. Volcanoes are a big part of the landscape here. With over 130 active volcanoes, Indonesia has more than any other country in the world. These giants can be peaceful, providing fertile soil for farming, but they can also wake up in explosive eruptions that impact thousands of lives. The eruption of Mount Merapi in 2010 is just one example of how sudden and devastating these eruptions can be. Earthquakes are another threat from living on the Sunda Arc. Since Indonesia is right on the edge where the Earth's plates meet, it's prone to earthquakes that can strike without warning. The 2004 Indian Ocean earthquake, which caused a massive tsunami, showed just how destructive these natural events can be. This earthquake, with a magnitude of 9.1, 9.3, was one of the deadliest in history, claiming over 230,000 lives in 14 countries and displacing millions. The sheer force of the quake lifted the seafloor by several meters, unleashing a series of powerful tsunami waves that reached as far as the east coast of Africa. In addition to the 2004 disaster, Indonesia has experienced numerous other significant earthquakes. For example, the 2006 Yogyakarta earthquake, which struck near the southern coast of Java, resulted in over 6,000 deaths and damaged or destroyed hundreds of thousands of homes. More recently, in 2018, a series of strong earthquakes hit the island of Lombok, causing widespread damage and loss of life, followed by a devastating earthquake and tsunami in Sulawesi that killed thousands. These seismic events show the volatile nature of the Sunda Arc and the constant risk faced by those living in its shadow. Indonesia's position atop numerous active fault lines, combined with its dense population and the vulnerability of many buildings, compounds the potential for disaster. The Indonesian government and international organizations continue to work on improving earthquake preparedness and response strategies. These include better building codes, early warning systems, and public education campaigns to minimize the impact of future quakes. Despite these dangers, Indonesia is at the forefront of learning how to live with the Earth's movements. The country has developed warning systems for both volcanic eruptions and tsunamis. Schools teach children what to do when the ground shakes, and communities hold drills to prepare for disasters. Researchers in Indonesia and around the world are studying the Sunda Arc, trying to understand more about why and how these natural events happen. This research is crucial. It helps improve prediction methods and ultimately saves lives by giving people more time to get to safety. Advances in monitoring and safety. In recent years, we've made big strides in how we keep an eye on the Earth's shakes and quakes. With new technology, we can now monitor seismic activity better than ever before. This means we can get a clearer picture of when and where an earthquake might happen, even though predicting the exact time and place is still challenging. One of the key advances in this field is the development of more sensitive and accurate seismometers. These devices can detect even the smallest tremors, sending data in real time to scientists. This information is crucial for understanding the patterns that might lead up to a bigger earthquake. Additionally, satellite technology helps us see how the Earth's surface moves over time, adding another layer of monitoring. Building codes and the resilience of our structures have also seen significant improvements. Nowadays, engineers design buildings and bridges with earthquakes in mind. This means using materials and construction methods that can withstand shaking, reducing the risk of collapse during a quake. These building codes are constantly updated as we learn more from each seismic event. On a global scale, there's a growing emphasis on disaster risk reduction and emergency preparedness. Organizations around the world are working together to share knowledge and resources. One example is the Sendai Framework for Disaster Risk Reduction, an international agreement that aims to reduce disaster risk and help communities manage the impacts of natural events more effectively. Countries in earthquake-prone areas are also developing early warning systems. These systems can give people a few seconds to a few minutes of warning before the shaking starts, allowing them to take cover. While it might not sound like much, these precious moments can save lives and reduce injuries. Education and community drills are another important aspect of safety. By teaching people what to do in the event of an earthquake, communities become more resilient. Schools, businesses, and neighborhoods regularly practice drills to ensure everyone knows how to respond when the ground starts moving. Advances in seismic monitoring, improved building codes, and global initiatives in disaster risk reduction are making us safer. While the Earth will continue to move and shift, our understanding of these processes and our ability to respond are better than ever. Thanks for exploring with us on Beyond Discovery. If you enjoyed these revelations, click now on the next video that pops up on your screen. It's unbelievable.